Okay, huh? So let's start our discussion tonight. Okay, so first, after we discuss the reactivity, right? Okay, next one is the chemical equation. Okay, chemical equations for the reaction. Okay, element R. So element R we can see here is a group 1, right? Okay, group 1 R. So it's a metal. So how is the chemical equation? R is a metal, so R. Most of you get this correct, huh? Very good. React with oxygen. Okay, so oxygen is O2 lah. Then we produce what? Okay, what is the product gas?
R2O.
Yes, R2O,
4R
right?
plus O2 is
R2O. R oxide lah. Okay, R oxide. Yeah. Then we have to balance the equation. So all here 2, correct? So this one only 1, so this one times 2. 2R2O. The other times 2, R also need 2 times 2 also. So 2 times 2 is 4. So meaning that you need 2 times 4 here. Okay. So all the formula correct, 1 mark. Okay. Then balancing, another 1 mark. Okay. So remember, all the chemical equation will be 2 marks. If one of the formula wrong, then 0 mark already, huh? Okay, next, where to keep the element S, R and S in the laboratory. So where do we keep it? Spelling is keep under paraffin, P-A-R-A, then double F, paraffin oil. Okay, in paraffin oil, Okay. Now here, what is the property? I expect most of you can answer this question, but somehow I think only 1 or 2 students get this correct. Okay, property of Q. Let's see. Q is here, right? I already told you if Q here, what is this actually? Anyone know? What is this? Group 13. Okay, group 13. Then what is that element actually? If we want to know the property of it. What is that?
aluminium.
Aluminium, right? Okay, aluminium. Okay, correct. Aluminium. Okay, since this is aluminium, Q here, group 13. So this one is aluminium. So meaning that here, if oxide of aluminium, so it's actually what? Aluminium oxide, no? Okay, so aluminium oxide, what is the property?
Amphoteric.
Yes, amphoteric. No, not many students get this correct. So coming exam, if same question come out, please remember M4 spelling must be correct also. Amphoteric. Okay, 1 mark. Okay. Any question? Okay, then H. Arrange the atomic size of the PQRST. Okay, here, class, you just arrange based on the follow the questions. Others no need to arrange here. So you just arrange this 1, 2, 3, 4, 5. 5 elements here. According to the descending order. Okay, descending order. Okay, descending order. So how is the sequence, class? Descending order meaning that it is arranged from
Big to
if
small.
atomic size, yes, bigger to smaller. Okay, descending. If ascending will be small to big. Huh? Okay, so class PQRST. We go back to the table, periodic table here. Okay, so PQRST. So we highlight out RST, P and Q. Okay, so class, which one is the biggest? Okay, so not many students get this correct also. So everybody, you pay attention one more time. Okay, if period 2 and period 3, okay, period 3 will be bigger than period 2. Okay, that meaning that STQ will be bigger than R and P. Confirm already, huh? Okay. Period 3 will be bigger than period 2, huh? Okay, bigger. So R and P will be smaller. Okay. But in the same group, okay, in the same group, in the same period, how is the size change, class?
Increase
Across the period.
number of protons.
Increase number of proton. Then your final result, the size will becomes
Bigger.
bigger or smaller across the period. Across the period, from left to right,
Smaller.
becomes smaller, huh? So meaning that if STQ, which one is biggest? Biggest? Paling besar?
S.
S will be biggest, huh? Okay. Then followed by T, then Q. Is that okay? 1, 2, 3. Biggest will be S, T, and Q. Okay, then only go to the period 2. So same case, same condition. R and P, R will be bigger. So this is number 4. This is number 5. Okay. So meaning that if ascending order will be, descending order biggest, S, then T, and Q, right? Then number 4 is R and P. Okay, so this is the answer. If ascending order will be reverse, STQ, RP. STQ, RP. S, T, Q, R, P. Okay, that descending order. If ascending order will be P, R, Q, T, S. Oh, so coming exam, don't get this wrong again, remember. Any question to ask?
No, teacher.
Okay. Okay, number 2. Okay, table shows the physical properties for group 17. Okay, group 17 here. Okay. Now here, chlorine, bromine, iodine. Okay. Now first melting point, then boiling point. Okay. So class here, going down the group here, chlorine, bromine to iodine. Okay. What happens to the melting point, class?
Increase.
Yes, increase, right? Okay. So increase. This one also increases, right? Okay. So class, later we see the questions. Okay, we look at the first, another name. I think you should be able to name this already. Halogens, but still got students. Okay, halogens, group 17, another name. Oh, okay. Now, atomic radius. Okay, atomic radius. Okay, change of the atomic radius going down the group 17. Okay. From chlorine, bromine, and iodine. Okay. Now, class, here, change in the atomic radius. In your level, right? Not supposed you to list out the value again. Okay. So if you list out the values, there will be no marks. No marks for the value. So here, change. Okay. Supposingly, you have to write what changes. Let's say increase, decrease, getting bigger, getting smaller, and so on. You have to mention the changes, not mentioning the value only. Understand? Okay. So atomic radius here. So we can see what happens to the atomic radius. Also increases, right? Okay. So you just mention increases. Oh? Or you want to mention atomic radius increases from chlorine to chlorine, bromine, and iodine. Okay? Because here mentioned already. Okay, increases. Okay? Then explain why it is increases. Anyone? Why it is increased? Okay, here I'd like you to get used to it. Okay, you go to your notes, right? Okay. We are talking about this group 17. Okay. Okay, group 17. Okay, already look at this page, page number 61, 61. Okay. Atomic structure. Sorry, the atomic size, atomic size. Okay, here. Can you see this? Atomic size increases, right? Increases. Why? Because increasing number of shells, okay, occupy with electrons. Okay, increasing number of shells occupied with electrons. Okay, page 61. Okay, so your answer should be, explain your answer, because the number of shells occupied with electrons increases, right? From chlorine, bromine to iodine. Okay, 2 marks. Increases 1 mark, and then number of shells occupied with electrons, another 1 mark. So 2 marks. Okay, so you write down here, page 61. You can refer there. Okay, any problem, class? Yeah, I saw some raise your hands. Any questions? Ada soalan nggak?
No.
No, Okay. Okay, next we continue. Okay, next is draw the arrangement of particles for bromine at room temperature. Okay, so bromine at room temperature. Again, we go to see the knots. Okay. Okay, just on page 61, right? Okay. Okay. Okay, here. Also page 61, the physical properties. Fluorine and chlorine is in the gas form, right? Okay. Bromine will be in the liquid form. Liquid form. Iodine will be in the solid. So here we know already, page 61, in the liquid. So how do you, how can you draw the electron arrangement of particles? So for liquid, liquid. Okay. So liquid, you can draw bigger a bit, Okay, some of it still stick together, but there are some spaces, maybe, okay, like this. Okay, but they're still like arranged quite closely. Cannot be too separated. If too separated, it becomes a gas already. Okay, draw slowly and nicely. Okay, in the liquid form. Okay, or not, class? This is the arrangement of particles for liquid. Then for solid, just reminders, if minimum is 3 times 3 layers, 3 times 3 layers. Okay. Now D, step 1 safety steps should be practiced when handling the chlorine and bromine in the lab. Again, we go back to the notes here. How to handle them, class? Let's see. Okay, it is poisonous, you have to remember, poisonous. So how to handle them? Let me see, got mentioned here or not? No, not mentioned, Okay, so it is acidic, and then it can vaporize easily, okay, vaporize easily. Let me see if got mentioned here or not. Okay, group 17, it will be vaporize easily. Okay, vaporize easily here means it will change to gas, it will change to gas easily, okay. So meaning that if it is changed to gas easily and then it is poisonous, so meaning that the best way, okay, I think I can remember only 1 or 2 students get this correct. The standard one, that is, if got experiment involve gases, okay, there is a specific place to conduct it, especially for those experiments involve the poisonous gases. We have to do it inside where? Inside a place called fume chamber. Okay, where is the location? In our chemist lab will be at the back there. There'll be two place with the transparent mirror there. That two actually is the fume chamber. Okay, so for safety purpose, the blue cabinet, I'm not sure it's blue color or not. The one with the glass, transparent glass. Do you notice that? It's a very big one at the back of our.
Teacher, is it the blue colored cabinet, teacher?
Is it? Is it
At
blue
the back.
color? Maybe
I don't
now changed color
remember.
already. I cannot remember what color is this. But it is maybe the red is the blue color lah. Previously is gray color. Maybe now already change color. Maybe they paint already. I'm not very sure. But there is okay, never mind. I will find it to you. I will show it to you. The fume chamber, fume chamber for the experiment that involved the poisonous gases. Okay. Actually, acid also we do inside the fume chamber. Why? Because the acid sometimes when, especially the dilution of the acid, it will release the vapor also, gas vapor also. Yeah. So practice handling. So conduct the experiment inside fume chamber. Okay. Okay. But there are some students, right? Do not inhale the gases. Correct also lah. No one will purposely go to inhale the gas, right? You're fainted, you'll die sometimes. So don't simply purposely go to inhale the gas produced. That is true also lah. Okay, but the first priority, if we must conduct it inside the fume chamber. Okay, now E. Okay, compare the melting point and boiling point of chlorine and iodine. Okay, this question, some students were confused. Why sometimes I need to explain using the atoms, but this time for this, why I need to explain using the molecule. Okay, this one now I want to show it to you. Okay, I already returned to page 61 just now. Is it 61? Okay, still under page, still under group 17, right? Okay, we talk about this melting point and boiling point. Okay, now here, relatively, all the melting points are low. Okay, why low? Because here, you see, molecules are attracted by van der Waals force, weak van der Waals force. Okay, but however, the melting point and boiling point increase going down the group. Okay, here already we got the answer. It will increase going down the group 17, right? Okay, melting point and boiling point increase going down the group. Okay, in other words, okay, class, here we have to mention, okay, compare the melting point and boiling point. So no need to mention the value, just mention, okay, what melting and boiling point of chlorine and iodine. Iodine, wrong spelling, typing error. Iodine is what? Smaller or higher? Sorry, lower or higher? Melting point, boiling point is lower, right? Chlorine is lower. If you want to mention about the higher, then you can mention the higher for chlorine, bromine. You put higher also can. Yeah, like say bromine, sorry, iodine is higher than chlorine. Okay, so this is the point number 1. Point 1. Okay, why the iodine is has a higher melting and boiling point? Okay, so we relate it to the force. What type of force, class? Just now we mentioned already. Is what? Is the van der Waals force, right? Okay, yeah, van der Waals force. Okay, since we learned the van der Waals force already in chapter 5, so we go a little bit, go down just for the diagrams here. Inside the chapter 5. Okay, I want to show it to you. Where is the van der Waals force? Okay, here. Okay. So you look at these diagrams. Okay. So class, we look at this van der Waals force. Okay, weak van der Waals. Okay, so this van der Waals force is between the molecules, right? Molecules here is the carbon dioxide, but inside the group 17, it will be like chlorine. You share the electrons. I don't draw all out. Chlorine molecule with chlorine molecules like this. They'll share the electrons. Okay. So this one is a molecule. This one is a molecule. So the van der Waals will be like this. Okay. So this is the van der Waals force. Okay. This van der Waals is a weak. Okay, it's weak. Okay. But when the size is atomic size here, okay, or molecular size here is bigger, then this van der Waals force will become stronger a bit. Okay. So we come back to our discussion just now. So everybody you see, the van der Waals force is between the molecules, okay, between the molecules. So you cannot use the atoms to explain. Okay, so now we come back here to page 61 just now. Okay. So intermolecular force. Okay. Intermolecular force of attraction or van der Waals force between the molecule is stronger. So in this case, just now inside the question, iodine and chlorine, which one is stronger, class? Which one is stronger? The van der Waals force. Iodine is stronger or the chlorine is stronger? The van der Waals force. Iodine, right? Okay, because the molecular size is bigger. Is bigger. Is that okay? Then if
Okay, teacher.
if the van der Waals force is stronger, then next point is what? Next point is more
Higher.
Attraction force is stronger, then more heat energy needed to overcome. Okay, more heat energy needed to overcome the stronger van der Waals force between the molecules. Okay, that's why some students you use the chlorine atoms here. That's why you cannot get the marks for this, because now we are talking about the melting point and boiling point. So we have to focus to the van der Waals force. Okay, clear or not, class? Okay or not? Okay, so meaning that, okay, we'll come back to our quizzes now. Okay, so point number 1, 3 points, right? Okay, so point number 2, what should we mention? Iodine is higher. Why? Because the iodine molecule, you cannot say iodine atom here. Okay, iodine molecule have stronger van der Waals force than chlorine molecules. Okay. Then point number 3. So more heat energy needed to overcome stronger force. In chlorine molecule. Okay, on that? Okay, stronger van der Waals force. You have to mention the molecules. You cannot mention the atoms or. Any question, class, for this? Is Arina here? Arina, did they mention?
Yeah.
Now okay on already? Why you must use the molecule here?
Yes.
Okay, so everybody, after we discuss on this, right? So you always refer back here and then do some revision. Otherwise you will forget. Okay. Then we continue to the next question. And then last one already, right? Okay. The reactivity. Reactivity. Hold on. Let me see. Stronger. Sorry. Correct. Jimin, you are correct. Not inside the chlorine should be iodine. No? Okay. Thank you, Jimin. Yes, it should be the iodine molecule. Okay, iodine, not chlorine. No? Chlorine lower melting and boiling point. Okay. This one also wrong spelling, iodine. Huh? Okay, reactivity of groups 17. Okay, for the reactivity, yes, we have to use the atom. Okay, so for reactivity, because it relate to what? Relate to gain or loss. This one is a gain of electrons. Gain of electrons. Okay, because when we talk about the reactivity for group 17 is a gain of electrons. So if gain of electrons, then we have to use the word atom, chlorine, or atom iodine here. Okay, or not? We cannot use the molecule. Okay, or not? Because involve the electrons, right? Okay. So group 17. Okay, reactivity. Which page we need to refer, class? Okay. Reactivity. Here is here, reactivity is page 62. Every day you look at 62. Reactivity, group 17, it has 7 valence electrons. Okay. How to achieve octet electron arrangement, accept or gain 1 electrons to form the negative charge ions. So meaning that how to become stable, need to accept or gain 1 electrons. Okay. So this is the main idea that you need to remember. Okay. But when going down the group 17, okay, atomic size increase, all right? Atomic size increase, getting bigger because the number of shells occupied with electrons increases, right? Okay. Then point number 2, okay, attraction, strength of attraction, okay, from the proton to the nucleus becomes weaker, right? Force of attraction becomes weaker. Okay. If the atomic size bigger, meaning that this attraction force is weaker, so more difficult to attract 1 electron, right? Difficult to attract 1 electron, so becomes less reactive. Okay, so fluorine more reactive, then chlorine, then bromine is the less reactive one. Okay, then. So here already mentioned here. Okay, so size of atoms is larger, force of attraction, okay, to the nucleus to attract 1 electrons is weaker. Okay, so not able. Okay, difficult to attract 1 electrons. Okay, so actually you can use the one before this here. Okay, I show it to you again. This actually you can use these 4 points similar. First point you mentioned which one is more reactive. Okay, then these 2 are the same actually. Point 2, atomic size, which one is bigger? Then attraction force between nucleus and electrons is weaker. Then point 4 is difficult. Difficult is less reactive one, right? But here is not released, it's to receive 1 electrons. Okay. So we can modify the F1, okay, as long as same techniques now, 0.1. Okay. So chlorine and iodine, which one is more reactive, which one is less reactive? You focus to one, which one you want to explain? Let's say iodine. So you can mention iodine is less reactive, right? Then chlorine. Okay. Then point number 2, here you cannot mention the atom is okay because we are not mentioning the gain electrons yet, right? Okay, so why? So first atomic size, okay, iodine atom has bigger atomic size than atom chlorine. Okay, or chlorine atom is the chlorine atom. Okay. Then if bigger atomic size, okay. Sorry. Or you arrange it inside. You arrange a sentence, the force of attraction in between nucleus and electrons is weaker in atom in iodine atom, right? Then chlorine atom. Okay. And point number 4. Okay. So iodine atom is more difficult to receive or gain 1 electrons. Okay. Then chlorine. Okay. To achieve stable octet electron arrangement also can. You can add in at the back. So 4 marks. Yeah, so you can see point 2 and point 3 is the same. It's the same. Okay. Any question, class? Okay, so you can see in this chapter more to like you need to understand and then you need to know how to explain. There are points that you need to remember. You need to remember so that you can score high marks in the exam. Okay, any question about this quiz here? Any question, class?
No.
No, okay. All can okay. So if no questions, okay, then I try to find out some more questions, okay, so that we can prepare for your exam. Okay, let me check. Okay, so this one is compiled by a teacher from other school. Okay, I just share with you all. Okay, so you do some revision. Quickly go through. It's a very effective way for you all to actually score well. We can do the questions. Okay, then see what is the requirement of the questions. Okay, now diagram shows the apparatus to determine the melting point of naphthalene. Okay, so yeah, now what is the meaning of melting point? This one I think in the quiz I already tested you. Okay, so you can refer back to your quiz. Don't get this wrong. Don't get it wrong again. Melting point, boiling point. Okay, so on. Now number 2, what type of particles found in the naphthalene? Okay, so here we already learn a bit on chapter 5, right? Okay, carbon. Plus carbon is metal or non-metal?
Non-metal.
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 Hydrogen. Hydrogen is metal or non-metal? Non-metal with non-metal. So it will forms what type of bond, class? Remember? Today we discussed the ionic. Another one is covalent, right?
It's covalent bond, teacher.
Yeah, covalent bond. Okay, it's a covalent bond, correct? Okay, covalent bond. Okay, covalent compound actually. Covalent, Okay, then inside the covalent, then what type of particles? Okay, particles here. Covalent compounds consist of what type of particles? Is under molecules. Oh, molecules. So remember, if you see non-metal, covalent compound, it is the molecules. Okay, so it's a molecules. Okay. Next, physical state. Physical state. A lot of students actually, you know what is that? Naphthalene is in the solid, but maybe you don't know what is the requirement. Physical state means what? Solid. Okay, so it is under what physical state? Naphthalene.
It's solid.
Yeah, that day you do the experiment, right? You take the naphthalene from the water, right? So it is quite solid, right? So physical state should be solid. Okay, keadaan physical, solid. Okay, then particles. Here, particles. Your answer should be atom, molecule, or ions. Okay. Physical state should be solid, liquid, or gas. Okay, then. Next, what is the purpose using the water bath in this experiment? Why cannot direct heat it? Anyone still remember? We have discussed this, right? To ensure what?
At a constant temperature when melting.
To ensure what? Even or
Temperature.
uniform?
Uniform heating.
Yes, uniform heating. Uniform heating or even heating. Yes. To ensure uniform or even heating. Okay. So meaning that the heat can be transferred into the naphthalene evenly or uniformly. Secara sekata lah. Okay, boleh? Okay, next. You get the graph like this. Okay. This graph here actually got some mistake. It should be a curve. Cannot be straight line. When you are asked to draw, it must be a curve. Cannot be a straight line. Must be a curve. Okay. Now, if the question asks you what is the melting point, class, state the melting point for this one. So is this one is T degrees Celsius, the melting point. Okay. Explain why. Again, this one very, very popular. Why there is no change? Standard answer. Why? Heat for heating, right? Heat absorb or heat release, class? Heat absorb or heat release? Yes, heat absorb. Okay, heat absorb. Used to what? Okay.
To overcome the force between the
Molecules here or particles. Heat energy absorb. Okay, surface part. Used to overcome the force of attraction between the molecules. Okay, don't write it is the melting point. No mark. So remember. So this one. Okay, here is, you can see the pattern of the question almost the same, right? Okay, like this. Why remain constant? Confirm if this question come up, you will ask this question. Okay, type of particles already mentioned just now. Okay, why cannot direct heat it? Okay, to ensure even heating. Why cannot direct heat? Another reason is, okay, it is flammable. It is flammable, meaning that if you heat it directly, if accidentally it catch fire, it can burn easily. The naphthalene. Okay, next. What we can replace it? Another one. Okay, like say acetamide. Acetamide. Okay, you'll get the same result. Roughly is also 78 to 80 degrees Celsius. Okay. Okay, now here, class. If I ask you, A to B, you see here 78 roughly. This one is the substance Z. We know it is roughly will be naphthalene also lah. Oh, okay. Now A to B, the temperature increase, right? Okay, B to C is the melting point. Then C to D. Class A to B, what is the physical state, class?
Solid.
Yes, it is solid only, purely solid. A to B. Okay, all solid. B to C,
Solid and liquid.
solid and liquid. Okay, C to D, purely liquid. Okay, so if you are asked to draw, okay, what is the melting point, class, for substance Z?
78.
78 here, 78. Right. So 78. If we write 78, still no mark, degree Celsius. Then only you get 1 mark. Miss out the unit to be no mark, so remember. A to B, here. A to B is solid, right? How are you going to draw it? Minimum requirement is 3 times 3. Okay, so meaning that 3 layers, 1, 2, 3. Minimum, you can do draw 4, 5 is okay, but minimum is 3. Then 3. This one is 3 times 2 only, cannot, not enough, so 3 times 3. Okay, so solid. Okay, again here, Y become constant. Okay, now heat absorb. Again, heat energy absorbed is used to overcome the force of attraction between the particles, right? Here you can see, except the intermolecular force, okay, correct, between the molecules. So, okay. Okay, you can see all the same. Okay. Now I want to talk about one thing here. Very important. Okay. Now you see, there are 2 types of, this is for cooling, cooling. It shows the graph of cooling curve of naphthalene plot by 2 different students. This is T2, this is also T2. But there is a condition called R. Oh, okay, state a significant difference between 2 graphs. Okay. What is the difference here? Okay. So we can check here. Yeah. For A, the heat is distributed evenly. Okay. Another one is, you can see temperature drop uniformly. This one is, it drops drastically. Okay, mendadak. Okay. And then heat is distributed unevenly. Okay. So meaning that why this one? Okay. Why this happened actually? Especially, I think there are some students or some groups that when you draw, you record the temperature, you drop, and suddenly it will go up again. Okay. Yeah. Previously, I have some students also faced the same problem. Then when you draw the graph, it will be slightly like this. The temperature drops, okay, below the freezing point, and then suddenly it will go up again. Then become constant. Okay, then it drops again like this. The correct one should be like this. This one is considered incorrect. Incorrect. Not correct. Okay. So now we discuss why this happened. Okay. Why this happened. So this phenomenon occur at the R means the temperature decrease below the freezing point. Okay. Anyone know this phenomenon is called what?
Teacher, is it super cooling?
Yeah, it's a super cooling. Okay, very good. Super cooling. Okay, it's called super cooling. How to spell, class? Super like Superman, super. Okay. Then cooling. Okay. So very important now this one. It come out in the SPM. I think is last 2 years. Last 2 years. Okay. It's a supercooling. Means the temperature drops below the freezing point. Then suddenly it go up again. Okay. Now, how to overcome this or avoid this happen? We want to get this actually. It drops and then it become constant for a while under freezing point. Then it drops again. This one is the correct one. But somehow, some student or some groups, they will get the result like this. Go down below the freezing point. Then you go up again, then become constant, then drop again like this. So how to avoid this class? How to avoid this? Okay. Or why this supercooling occur? Normally is because of when the cooling process is done. Okay, the student just let it like that. Okay, let it be. Okay, put the thermometer inside the naphthalene, then just put there. Okay, then most probably it will form it will occur the supercooling. Okay, then how to avoid the supercooling? Very simple. You have to stir. Okay, kacau dia. Naphthalene needs to be stirred continuously. Okay, stir continuously. Dikacau secara berterusan using thermometer. Okay, understand? So how to avoid the naphthalene need to be stirred continuously during the cooling. Kacau dia secara berterusan. Okay, so in exam, if this question come out, you should know what to do. Okay. So stir naphthalene continuously. Okay. Using thermometer during cooling process. Okay. So the keywords here, it should be stir continuously. Stir continuously. Okay. These are also still the same. Okay. This is cooling. Here using the acetamide now, right? Acetamide, the formula is slightly different a bit. Okay. So, but you can see the freezing point, melting point is almost the same, 80 also. Okay. Now, why temperature remain constant during the cooling process class? What are the points? Now, heat is what? Heat is release, no more absorb. Heat energy release. Okay. To surrounding. You can mention this one first. Heat loss to surrounding. Is the same as is balanced by the heat energy released when the particles attract to one another. Okay, these two are the same. You can write this one first, this one second is okay, or you reverse it also correct. No problem. Heat energy lost to surrounding is balanced by the heat energy release when particles attract each other, or heat energy release when particles attract each other is balanced to the heat energy lost to the surrounding. Okay, meaning that this one is equal. These two value is equal. So meaning that the temperature remain constant. Remain constant. Okay, again the same thing. So you can see a lot of trial questions are almost the same questions. Okay, now we go to this one, SPP, SPP. SPP's column berasrama penuh, the standard of the question is very high, very good question. Okay, aluminum is used in food packaging, food packaging. Okay, now what is the physical state of aluminum? Okay, at room temperature, class.
Solid.
Again, aluminum, right? It's a solid, Okay, good, solid. Write the symbol for the aluminum. Okay, is what is A, L, A, L, Okay, now here, protons and neutrons is 13. 13 is proton. 14 is neutrons. Okay, now what is the term used for the total number of protons and neutrons in the nucleus? What is the terms?
Is it nucleon?
Nucleon? Halfway only. Nucleon what?
Nucleon number?
Number, yes. Okay, nucleon number. Okay, then sometimes the question will change. Define nucleon number. Then your answer should be the total number of protons and neutrons in the nucleus of an atom. Okay, that so in SPM also will ask you to define. This one is a SPM question. So whether this one or this one, then you have to remember. Then draw the electron arrangement. Okay. So electron arrangement class, do we need to include the nucleon number and protons and the neutrons? Need or no need?
No.
No need, no need.
No.
Okay. No need, just electron arrangement only. Here, be careful on that. Aluminium ions. Not atom, class. If atom, if aluminium atom, what is the electron?
Use its proton number.
So it's 13, right? 13. 13 protons so means 13 electrons. So if we arrange it, 13 electrons, how do we arrange? First shell we put in?
2.
How many? 2. Okay. Shell number 2?
8.
8. Okay, then remaining? How many left? 3, right? Okay.
3.
This is for atoms, right? Atoms means originally. Protons same as electrons, Atoms means proton same as electrons. Okay, sama lah. Okay. Then if ions,
minus 3 electrons.
Yeah, meaning that achieve octet already. Octet electron arrangement. Okay. So here 2H3, how to achieve octet?
Lost 3 electrons.
Lost the 3 electrons, all right? Lost 3 electrons. So it becomes 2, 8, right? 2, 8, lost 3 electrons. So after lost 3 electrons, what is the charge?
3 plus.
3 plus. Okay, because now proton is more 3 units, electron less 3 units already, so meaning that here is 2, 8, then we can start to draw our electron arrangement already. Okay, so step 1, in the nucleus, write down the formula Al, then draw the nucleus. Okay, so nucleus, don't put in any electrons for the nucleus. And then shell 1, then only you put in. And shell 1. Shell 1, you put in 2. Okay, 1, 2. Okay, then shell 2. 8, right? 1, 2. 5, 6, 7, 8. Okay, 2, 8. If you leave like this, also wrong, huh? Why is wrong? Because you need to put in the charge, right? So how to do it? We put in a bracket normally, then we write down the charge 3 plus. Okay, no? Any question, class? Okay, huh? Then continue. Time already. 24 already. Okay, again, isotope still remember that time I test for a few times already. Siapa yang belum dapat hafal, please go to memorize it. Okay, isotopes, atoms of same elements. Okay, atoms of same elements. Okay, this one still not correct. Atoms of same elements have the same protons, different neutrons. Okay, so 2 parts, 3 parts. Same proton, different neutrons. Okay. Okay, now P, Q, and R. Same protons, different neutrons. Okay, so which pair they are isotope? P, Q, and R.
P and R.
P and R. Okay, P and R. Then if the question will ask you why, then you mention they have same protons number but different nucleon number. P and R. Isotopes normally is 2 lah. So P and R. Okay. Okay, now determines number of electrons and neutrons for each element stated. 2 marks. Okay, P1. So what is the electrons for P and R? Okay, P. How many electrons for P? 6, right? Electrons. Okay, how many neutrons? How to get the neutrons, class?
The nucleon number minus the proton number.
So 12 minus 6. So 6 neutrons, right? Okay, then how about R? R, how many electrons?
6.
6 electrons also. And how many neutrons?
8.
8 neutrons. Okay, class? And on it. Again, the same thing, same thing. Okay, now should be no problem. Okay, so I think we stop here tonight, and then we continue again next Friday. Next Friday, we also discuss some of the questions, trial questions there. So my planning is we try to, maybe I ask you to photostat, okay, and then you pay for the trial question set. Then during the Friday night, we do the trial questions. So the more questions you do, then next year you can see your SPM result will be much more better. Okay, So, okay, any more questions before we end? No, okay. So tonight 41, roughly 41 to 44 students. Okay, so hopefully more to join up. Okay, thank you class for your attention. Yeah. Okay, bye bye.